Benim ismim Vahid. Öğretim üyesiyim ODTÜ'da. Informatics Enstitü'de. Aslında Azeriyim, o yüzden de Türkçe'ne biraz konuşabilirim. Yani iki dilde galiba konuşabilirim ama çok İngilizce de hazırladım. Sonra da Sabbatical Leave'deyim. University of Calgary, Kanada'dan. Orada bir süre yaşadım, çalıştım. So bugün Android'in automated test suite'lerine bakacağız ve onların yani bir de ki defect density yani hata yoğunluğu Android'da. Yani bilimsel. So this was a scientific research that we conducted in the University of Calgary, and today I will report some of the results. So let's briefly look at Android's architecture, software architecture, and we did some measurement of its code base, metrics, line of code, code coverage, if you are familiar with, defect density, and a few other metrics. And I will also give you an overview of automated test suites that come with Android code base if you download it. I'm not sure if you are familiar with them. This one so I can see it better. And then sound resonates. And then we will look at the results, right? So so we are going to look at different packages of Android. For example, Activity Manager and different applications, email, browser, how many defects have been reported for them, and how it relates with the amount of code coverage that you get with automated tests that have been written for them, either in unit test level or UI test level. And we can also see in the manual that, in the program that also there are a few other talks talking about the test platform of Android. So I think there's perhaps some similarity between the talks. So we looked at the version 2.1 of Android, which we have here. Where's the mouse? So this shows the evolution of Android. I'm not sure if you have seen this nice, interesting, and cute picture. So 2.1 was released in summer 2010, and we did this, this investigation in that year, in 2010. So now we are in much newer versions. We are now thinking version 4.1 as of July 2012. Anyways. So this was done on that version, and then so we downloaded the whole code base, and we did lots of measurements on its test automation and on its test suites. I think you are familiar with this, so let's review the architecture of Android. So in the bottom level, right, we have the Linux kernel, which is the OS essentially, and talks to the hardware. So you have the display driver, keypad driver, Wi-Fi, camera, audio drivers, and etc. And it's a mini Unix, right? So they have taken the Linux and they have minimized it. And so the reason that I'm mentioning this is that we look at the automated tests for each and every of those modules and packages. On libraries, you have Surface Manager, OpenGL, Media Framework, SQL Server, and etc. So those are the libraries of Android, and then you have the Android runtime, which is the JVM, Java Virtual Machine. And then we go to application frameworks, which are again kind of SDKs and APIs. And then in the top, we have the actual applications that some of them, of course, come standard with Android itself. Browser, email, phone application, contacts, and of course there are many other apps that we develop and we purchase and we download on our devices. So when we started this, so we looked at first the Android code base, right? So we said, well, how many lines of code you have and different types of, what programming languages and what are the programming languages, right? So most of it is in Java and C++, as we can see. So total line of code was about 9.3 million line of code. So when you download it, and so we counted the number of files, it was about 54,000 files. Line of code by language, so you see about 6 million lines is in C and C++, and of course the reason for this is that most of it is in Linux, so they have taken the Linux and they have adapted and modified it. And then Java, because Java sits on top of the C and C++ OS, and then SQL and some SQL files and XML files and web files, etc. We measured some more, more detailed metrics. So we looked at different methods, object-oriented methods in the code base. We measured the average line of code was about 8.7 line of code. So showing, again, you can compare it to other, open source or other major applications, and you can just do some benchmark with that. If you're familiar with McCabe complexity, which is another code metric, which shows, I have provided some a brief definition in the bottom. It's the average number of control flow paths for a method, for a function. Essentially, it is if you have, for example, if then else statements, right? You have if then else, so it will be like 2, right? So you have 2 control flows. So on average, it was about 2.5 for the whole code base. So it shows, the medium complexity, of course. And then, for example, maximum method line of code, so there was a method with about 3,000 line of code, and there was a method with 284 control flow paths or branches, so which shows quite complex for one single method. So there were that many paths. We looked at, so on the same data, here I'm showing the histogram or frequency diagram of the same information. So here on the x-axis you have line of code, and on the y-axis you have number of methods. So there were about 20-something thousand methods having one line of code. And perhaps I can raise a question to you folks, what kind of methods those could be, having one line of code. Any guesses? Pardon? Constructors or setter or getter functions, right? Because you have set and get function, just set like equal something and then you say return. So most of them were those kind of stuff, or constructors, or with one line of code. There were about 5,000 methods with no line of code. It was just open bracket, close bracket. So again, this just gave us a statistical view of how the code base looks like. Here you have the McCabe complexity, this histogram for that. More than 40,000 methods had complexity of 1. It means just one flow, no branches, no if then else, no loops, just one control flow. And then we just did again another more beautiful looking image showing again line of code versus McCabe complexity. So over there you are seeing about in the red chart about 50,000 again methods. So again, one would expect that as line of code increases, right? So you have 0, and this is, oops. So you have 0 and 500. So line of code increases in this direction, and McCabe complexity goes up 50, 100, 150. So again, one would expect an ideal, situation that with increasing line of code, you will have increasing McCabe complexity, perhaps. And that's kind of the case. You can have a kind of regression line like that. So this was just again, I'm making it very brief because it's about 15, 20 minutes time for me. I can point you to the whole detailed, article. So now let's look at the automated test suites. How many of you are familiar with automated testing? Okay, so it's good. It's about 6, 7 people. So JUnit, right? So you know that the automated unit testing for Android is based on JUnit, on the unit testing, and the UI testing also is supported. We're going to talk about both of them. I've just pasted here, a simple, of course this is not about Android, just an example of JUnit for those of you who are not familiar with it. For example, suppose you have written, a little class called my class, like a hello world, to do some form of multiplication. If you want to test that it works properly, right? So you create a new object of that type, and then you pass 10 and 5 to this object, and you call the multiply, and you want to ensure that it actually returns 50, which is a multiplication of 5 and 10. So here really we write code to test other piece of code. So Android of course supports this, and again when you download the open source OS, it comes with a lot of test cases. So here I'm showing you an example, a real test method from the Android code base itself. This unit test checks that the emergency number, which in North America, as you know, it's 911. I'm not sure what's in Turkey. Is 120. Well, that 911 is set properly, right? So again, there are some details here, but essentially what it does. So you are testing that 911 is there, and then you say assert is valid emergency caller info set, etc. Of course, that's another function that's written somewhere else, so we don't have the code for it here. But so the whole logic is that. And so automated tests provide lots of benefits, right? They make your testing repeatable, and of course, in the long run, hopefully cost effective. Because you develop it once, of course, it's like a investment. You develop it once, you spend time to write this test code, but once you have it, in next iteration and next versions, right, you don't have to manually test everything. You just press run, it runs nicely, hopefully without too many changes, and of course there are issues as well that we have to consider. But the whole again logic is that, for example, these numbers are, because of course it's very important that a phone is able to call emergency numbers in any situation, even the lock mode, etc. And then there's another number here, 1-800 number, which are free calls in North America. And then you say assert false this number. So this number shouldn't be an emergency number because it's not. So it's just like so you have two. So you really have essentially you have three test cases here, right? For one for this, and then one for the negate case or the false case. So just, I want to give you an example, right? So we looked at all these things and then measured coverage and a few other things that I'm going to show you. This is an example of UI test in Android. Again, I'm sure you can see lots in the other tutorials in the internet, but to give you a flavor of what it looks like. For example, this test, this is a long name. Test arrow scroll down to bottom element on a screen. So what it tries to do, apparently, you have this kind of screen, and you have that, the little ball there, right, and the keypad. You want to just scroll it to the bottom. You want to ensure that if you scroll it down, it actually goes to the last bottom on the screen. So it's kind of very detailed kind of mechanism and intent that you have here, and you want to verify that. So there's a bunch of works, steps are being done, and so get activity, as you know, returns the actual instance of the application that is running. So you get its number of buttons. You're getting the last button. You try to scroll to the last button, and then you do some verification of the height of the last button with the layout height, and they should be almost the same. So if it fails, it will give this kind of message. I'm trying to and then depending on number of groups that you have on your UI, you're sending the down pad key event, and just tries to go down, etc. You do some, so you're waiting for the synchronization because the UI takes some time for synchronize, so you make it, if not, then the test may fail, so you have to again, make them synchronized. And then, of course, you ensure that the last button has focus. If it doesn't have the focus, like the red color or whatever focus color, and then again you check that the bottom should be at the very bottom of the screen. So again, these are the examples of UI tests that have been written for Android by the team that have been involved behind it. So we now looked at again the whole test suite that came with version 2.1. We tried to do some measurements again. These are the line of code metrics. So in Java language, there were about 357,000 line of code of JUnit test code. So which was about number of test methods. About 13,000 JUnit methods were written. For example, this was one of them. So there were 13,000 of this kind of tests. There were some tests written in CPP unit for C++, the OS part of it, but that's kind of negligible, 5,000. And the reason we thought was that because Linux has already been tested quite rigorously, by other Linux groups and etc. There's also another, of course, project, Linux test project, LTP, if you have heard of, that IBM, a few other companies are behind that. They are writing tests for Linux. So that for that reason, Google perhaps didn't have to test the Linux that much. When it was ported to Android. So number of asserts. So we try to count how many asserts you have, and then we tried again to count how many unit tests versus UI tests you have in that version. So you see the majority are unit tests. There were also some good amount of UI tests. So 71,000 line of code. Okay. So now let's go and see. So this was kind of more like background. So now I want to kind of show you what kind of a study we did actually, again to measure test coverage. And so perhaps can I ask how many people are familiar with test coverage? Test coverage, it's good. It's a good number, thanks. So we wanted kind of to look at 4 things. So the goal of the case study was to assess test coverage. I'm going to give an example next, again for those of us not familiar with it. Fault detection effectiveness. So I want to see, well, if we write automated tests, right, how many faults we are detecting? Because, again, the goal of testing is, of course, to find faults or to ensure that there are no faults. And then test cost effectiveness. So when you write test coverage, right, you're spending effort and cost. And when you find faults, that shows the benefit of testing. And then cost effectiveness was kind of the measure for return of investment, ROI. So we want to see if I, for example, write these many tests for this particular package, and I write some others for other packages, how they will compare with one another in finding faults. So kind of analyzing that. The last one was defect density, which is defined as number of defects per kilo line of code. So kind of how many defects you have for for different packages in terms of density. Okay, so just a quick example of test coverage again for those of us not familiar with this concept. So this is a screenshot of Eclipse. I think actually it's not for Android, but I mean, of course, in Android it will look the same. So if you have a Java code base, or in any other, of course, language, so we have tools. So you write again automated tests similar to the one that we saw, and then on the code base, right? Suppose you have a function here, add all, and doing some stuff here. You have if then else's. So you run your test, and you want to make sure. So you're looking and analyzing which lines are covered. So green means it has been covered, or it has been tested, it has been executed. Red means not executed, and good, like yellow means kind of partially, kind of halfway. So when you do all that, again, we have tools that that give you these kind of percentages. For example, it says this class, array stack and some bag utilities, you have about 86% coverage. So it means the number of lines, so 86% of lines have been covered. Of course, as a test engineer, right, our goal is to increase this to 100% as much as possible. So again, in automated testing, this is one of the, of course, important measures that we want to use to improve our test activities. All right. So we try to measure this for Android again. I'm going to mention, so we measured these 5 things: coverage, fault detection effectiveness, coverage versus number of actual reported bugs in the bug repository of Android, and correlation between that and that. Because of the time limitations, 2 minutes, we'll look at perhaps the number 1 and 5. Research questions for number 1 and 5. So in terms of code coverage, so this graph shows, so I think I have 11 or 12. So these are the different packages of Android that we try to measure coverage. You have the framework package, which is kind of the baseline for writing any application. Email package, which is the email application. Calendar application, browser application, global search. The global search is, when you come to the first screen and you search in everywhere. So, and these again come with coverage. So we tried to, so this shows the number of line of code, which is in logarithmic scale. So you have about, this is about 10,000 lines, for example, for calendar, and this shows number of lines covered by the automated tests. So when we look at it, right, so you see a variable kind of trend. It's not that homogeneous. So let's try to make sense out of it. For example, you have these many packages. They're all kind of a similar size, but they have different coverage metrics. So you can say, well, global search is smaller than calendar in terms of size of code, but it has been tested more. So you will start to ask questions, why that's the case. Right? So there are many questions that we tried to ask, of course. Answering them wasn't that easy. We came up with some potential reasons for such an imbalance in test strength or in test effort that has been spent by the team behind it. For example, we thought, well, code reuse. For example, it's, well, when we investigated that, we found that, for example, the calendar package in Android has been reused from the Google Calendar project. They have taken that and they have, of course, changed the UI part of it. So perhaps because in Google Calendar project they had done more rigorous testing, they didn't have to test it very hard here. So these were just some potential reasons which, of course, we are not even 100% sure that's the case, but still you can try to guess some stuff. And risk-based testing, so that's another thing that testers follow. They say, well, whatever is more risky, I have to test more, or whatever I expect to have more faults when people are going to use it. Or some people call it fault-based testing or risk-based testing, so that kind of terminology. So again, you may say, well, email is going to be used perhaps more than calendar. I'm not sure actually that's true or not. But for example, email has been tested more than the calendar here. Because again, you expect people to use it more often. You see a bunch of dots here. I hope it doesn't look confusing. But so this is more fine-grained coverage measurement. So we looked at each method, each class. Because this was in package level. And as you know, each package in Android will have many, many classes, in Java code base. So this is the code size of each Java class. There were about 10,000 classes. And 9,000 something, and then line coverage. So again, you see a variety of spectrum. There were many classes, Java classes, of different sizes, but with zero coverage, so it means they had not been tested. But at the same time, there were some classes that have been tested quite rigorously. Again, we tried to find the reasons why that's the case. Okay. I will mention this and then hopefully we should be done, okay? Bu da bizim son slide'ımız. Code coverage versus number of actual reported defects. So what we did actually, I think, okay, the image is here. So we wanted to know, right, how many defects have been reported for each package or application app of the standard Android version. So we went to the Android issue repository that perhaps you have seen. And of course, people keep reporting bugs and issues and features and feature improvements and enhancements. So for example, for the camera application, so what we did, we just put here camera and type equals defect. For example, the return was 776 defects. So we counted the number of defects for each application. And so what we want to know, right, our idea was like this. If an application has been tested quite rigorously, right, meaning that high coverage, will it have low number of defects? Because that's what you would expect. You say, I tested more, so hopefully there will be less defects. So we wanted to investigate and see if, what's going on in this regard. So this shows the results. Again, it's all over the place, kind of. This is the line coverage percentage, and you are seeing here different packages of Android. Again, camera application, music application, that we play music, MMS, the multimedia message service, calendar, contacts, email, and etc. Download provider, and the number of defects in the issue repository. So, for example, on one extreme we have music. Music has been tested, quite not well, perhaps in terms of at least automated testing. But again, it have had lots of defects reported by people, by users. On the other hand, global search, so you again has been tested quite well, and it had low defects. So that's perhaps. So again, you expect a trend like this, right? So you expect a trend like this. So with more testing, you expect less defects in a statistical sense. Well, that's kind of the case for these guys, for these 4 applications, but these ones kind of fall out of the trend line, as you can say. So, yeah, that's, I think, pretty much it. I think, yeah, I will stop here. Eğer sorularınız var, buyurun lütfen. Buyurun.
Kompleks arttığı için az önce gösterdiğinde sadece internet için daha az sayıda test varken yeni test sayısı çok daha fazlaydı. Zaten user internet yeni testlerle kapsandığı için sayısı az, yoksa return of testing az olduğu için de o kadar üzerine düşünüyor.
Çok iyi sordu ama açıkçası yani bunun...
İkinizi alabilirim en azından. Hani cevapları çok ihtimalle. Bu arada teşekkürler şunun için.
Tamam. Yani tabii ben kesin cevap veremem çünkü yani user interface'in çok challenge'ı var mesela automated user, çünkü değişen zaman yani o testler çok reusable olmuyor da, yani user interface'te mesela button falan olar evolve olan da, yani mesela o buttonlar çıkıyor dışarıya ya geliyor falan, bunlar hepsi sebep olabilir. Bu bir sebep, yani potential sebep. Sonra ve galiba mesela UI mesela galiba çok manually test ediyorlar. Çünkü mesela olan alfa ve beta mesela test phase'ler var. Mesela client user geliyor mesela site'a, mesela orada mesela kendileri application'ını test ediyorlar ama unit testi manually test etmek olmaz çok yani. Çünkü source code level'de yani manual test yapamayız çok.
Framework'ta üzerine kurulu olduğu için user interface'ler daha çok. Framework'in unit testi yeterince kapsammışsa user interface'in
çok gerek yok galiba, mesela öyle diyebiliriz. Çünkü sen tabii UI testler sadece tabii unit test eğer iyi test olmuş olsa UI onun üstündedir ve sadece mesela tabii o UI'den o GUI ve Unity'nin interaction'ını test ediyor. Çünkü business logic'ini test etmiyoruz çok UI'da. Bu da hepsi potansiyel olabilir. Buyurun.
The quality of the tests that are written for these research.
What do you mean by quality?
You can write a unit test, it's just one line of code or...
Very good question. Well, in this study we haven't looked at it, but that's of course, have you heard about test smells, for example? There are some discussions in that regard. Actually, there's a good book, Extreme Test Patterns. Yeah, right. So, well, on another code base, we are looking at the same issue.
Probably the Google's code, but did you have access to unit test or anything like that, or any kind of information that, okay, we are Google, we are running a unit test, or you just assume some kind of some quality for unit test?
Yeah.
Is research based on that assumption? Or?
Well, again, if you have enough quality, I think it would be, this is a very valid question, very valid, we should of course measure the quality of tests, because just like in software, it should have good quality. We haven't measured it, unfortunately, but, but for example, I showed you, for example, in the 911 example, right? People tend to put several assertions in one test method, which is an greedy test, which is not good. If one fails, the other one will not execute. That's one example thing. We have systematic analysis for this system, but we have the limit for some other source code bases. Any other questions?